Let's go do it one more time. Let's do it reverse. Let's try to put all of these together. So first thing I want to do, get in that cabin, everybody. ln of x squared plus the ln of y cubed. Those two are being added together. So I want to write it as a single logarithm with their insides multiplied. The ln of x squared y cubed. Next one, bring in those threes. Bring in that 3. So log a cubed minus log b to the 1/2. Now I could leave that 1/2, or I could also make it a square root of b. I'm going to leave it at 1/2. No, I'll make it a square root in this next step. So we get log. They're being subtracted, so they got to be over each other. A cubed over square root of b. Now, hey, remember, we're not allowed to leave square roots in the denominator, so I need to multiply numerator and denominator by the square root of b inside of that logarithm. We end up with log a cubed. A cubed times the square root of b is just b. And the square root of b times the square root of b, b. Done. This is one that the book might write this, but I'd probably take this as well. All right, nope, a couple more of these, write it as a single logarithm things. So bring everybody in. When I bring everybody in for this one, make sure that the 3 gets cubed and the y gets cubed. Everybody's got to get that cube. Same thing with that one. Now let's decide who gets to go upstairs, who gets to go downstairs. So upstairs person, x squared. Z cubed is also positive, so it gets to go upstairs. That 3 cubed and the y cubed are not being positive, so they're going to go down in the bottom. 3 cubed is 27, and y cubed is just y cubed. If you wanted to, you could put parentheses around all that. All right. Here we've got a couple things that need to go inside. So we got log base b of x cubed. Nothing to put in with this one, so we'll just leave it alone. B of 4, and give that 2. All right, who gets to go up? Who gets to go down? Up in the top, we've got x cubed. We also get that 2x plus 1. It also gets to stay up. But the 4 squared is being negative, so guess where it's going? In the bottom. 4 squared is 16. Done. So one way that we might want to do this expansion is if maybe we know what log 2 is, and we know what log 3 is, and we know what log 5 is, but we can't figure out what log 15 is. Well, we actually can. So we've got log of 15. We might want to expand this thing because I know what 2, 3, and 5 are. So I think, is there something I could do with 15 to make it a 2, 3, or a 5, or some combination of that? Well, 15 is 3 times 5. So this equals the log of 3 plus the log of 5. If they're being multiplied on the inside, we can add them together. So we know what log of 3 is. We were just told it's b. So this equals b plus whatever the log of c is, which we're told is 5. So we're able to write log 15 in terms of b and c. We don't need to figure out a third thing. We can just do b plus c. Let's try 30. Let's see. So I know 6 is 2 times 3. Oh, but 2 times 3 times 5, 6 times 5, that is 30. So this is 2 times 3 times 5. 6 times 5 is 30. So that is the log of 2 plus the log of 3. I don't know why I put a parentheses there, plus the log of 5. So that is a plus b plus c. Neat. Let's try 12. Well, I know 4 times 3 is 12, and 2 is 4 squared. 4 is 2 squared. So let's rewrite this as the log of 2 squared times 3, because 4 times 3 is 12. So that is the log of 2 squared plus the log of 3, which is also 2 times the log of 2, bringing that 2 in front, plus the log of 3. So this is 2a plus b. All right, let's see, log 1/9. Well, I know 9 is 3 squared, so let's start with that. So this is the log of 1 over 3 squared. Well, here, let's just go with that. Let's just go with that. So then we get the log of 1 minus the log of 3 squared. Oh, but we know what the log base b of 1. If you put 1 into any logarithm, you get a 0. So that is just 0. So this is 0 minus 2 times the log of 3, which equals negative 2b. Oh, cool. Now 1.5 is a little sneaky. It's a little bit sneaky. So 1.5, that is the same as 3 halves. 3 divided by 2 is 1.5. So that is the log of 3 minus the log of 2, which equals b minus a. Neat. They're kind of cool puzzles. There's other ways that you could probably do some of these or come up with answers, but they're meant to be just like little puzzles, like how you can kind of like play around with these logarithms to get things that you do know if you have something you don't know. Final thing that we'll talk about is this idea of the change of base formula. I'm not a big fan of this thing. Mostly what I'm trying to do is trying to teach you how to think with logarithms in your head. And the reason I don't like the change of base formula is it's just typing stuff in your calculator is all it's doing. But there are times where we need to calculate bases, like logarithms to specific bases, and we don't have the answer to it. So we need something so we can do it. Change of base formula. So to do it, you can use common log or you can use natural log. The only difference is natural log uses one less letter. So I often use natural log, but it's the same number of button pushes on your calculator. So to evaluate the log base 4 of 7, so 4 to the what equals 7? I don't freaking know. It's some gross decimal number. So what we're going to do is we're going to do the natural log of what's inside of our other log over the log of our base. Our base always goes on the bottom. So we want to do the ln of 7 over the ln of 4. And I'm just going to go to my calculator. I'm just going to type that in. The ln of 7, clear. ln of 7. I'm going to close the parentheses. Then I'm going to press my divide. That's probably the only thing that goes wrong here. And I get this. So here you can see what I'm getting on my calculator. Hooray! So it is 1.404. If I did my next one, I get the ln of 20. Base goes on the bottom, ln of 8. So I go to my calculator, ln of 8, close the parentheses, divided by the ln of 20. You don't have to close the second one. Notice I'm not closing the second one. I'm just closing the first one. So I get 0.694. So it's approximately 0.694. So this one should technically be approximately. One more. So we do the ln of what's in the numerator. Again, sometimes I just cursive my L's, and I just do. I think I was trained to do that at one point or another. Like my math teacher did it, and then I just started to do it. But the thing is, it comes and goes. Like it doesn't always happen. So this is approximately 1.585. You can see what I'm typing in my calculator. Be careful that you close that first parentheses. If you don't close the first parentheses, you get the wrong answer. Here, let me show you. Check it out. See, those don't match. They're close, but they don't match. So if you don't put that parentheses there, it shoves the second logarithm inside of the other one. We don't want them inside each other. So that's it. That's it for our logarithm stuff. Thank you for watching all this stuff. A lot of material today. I'll probably cut it down. Hopefully you watch the bonus videos as well. But remember, this is a lot of this stuff, the bringing things in front, the adding and subtracting, those are the product, power, and quotient rules that we learned with regular exponentials. So logarithms are the same thing, just a new language. Thanks. Bye-bye.